Class 11th, Subject Physics, 11th Chapter, Electric Currents through Conductors. From this chapter, let us see electrical energy and power. So, the mechanical energy is defined as the capacity of a body to do work, and the mechanical power is defined as the rate at which work is done, that is rate of doing work is called as power. Now similarly, in case of electricity, we will have to find out electrical energy and electric power. So in order to obtain the expression for electric energy and electric power, let us consider a resistance AB connected to a cell with current I flowing through that resistance from terminal A to terminal B. As this cell is connected between the two ends A and B of this resistance, this is positive terminal, this is negative terminal, and therefore current will be flowing from positive terminal to negative terminal, and therefore through this resistance AB, current is flowing from A to B. Therefore, point A will be considered as the point at higher potential and B will be as the point of lower potential, because current always flows from higher potential point to lower potential point. Now, when the current is flowing through that resistance, that is, the cell is maintaining the potential difference phi between the terminals of that resistor. So as soon as that current is passed through this resistor, at that time this cell will maintain a potential difference of phi volt between the two ends of that resistance, that is A and B, and hence that point A is considered as point of higher potential, B is considered as point of lower potential. Now, as current is flowing through this resistance, that means actually charges are flowing through this resistance, and therefore let Q represents the charge flowing in time interval delta t through that resistance from terminal A to terminal B. So along this path, let Q be the charge flowing through this resistor from terminal A to terminal B for a short interval of time delta t. Then the potential difference between A and B, the potential difference between the two ends of that resistor A and B is equal to the amount of work done. That potential difference will be equal to amount of work done W to carry a unit positive charge from terminal A to terminal B. So this potential is nothing but it is the work done per unit charge, and therefore we can write phi is equal to W by Q, that is potential phi will be equal to work done W upon charge Q, or from this W is equal to phi into Q. W is equal to phi Q, equation number 1. So this equation will give us the work done to pass that unit charge or that charge Q through that resistance R, and therefore now the cell provides energy through the charge Q. This cell will provide energy through the charge Q to the resistor where work is done or where work is performed. So in this case, this cell provides the necessary energy to pass that charge across this resistor, and at that time work will be done. So when charge Q flows from higher potential point to lower potential point, at that time there will be decrease in the potential energy, there is decrease in its potential energy. So when that charge is moving from higher potential point A to lower potential point B, at that time there will be decrease in the potential energy of that charge, and hence the decrease in potential energy will be given as this decrease in potential energy is equal to delta U equal to Q phi, because energy is equal to charge into potential, since potential is equal to energy per unit charge, and therefore we will get phi is equal to delta phi q will be equal to delta u, that is delta u is equal to q phi, and that will be equal to, as this q is considered, it is charge, it is related with current I, as charge is equal to current into time. Now if I represents current and delta t is the time, then q will be equal to I delta t, and phi will remain as it is. Therefore delta u equal to I delta t into phi, equation number 2. Now this equation delta u gives the electric energy of that resistor. So this will be the electric energy, where I is the current and delta t will be the small interval of time, and therefore according to law of conservation of energy, if this amount of energy is present there, the energy converted in another form, because some part of that energy will get converted into another form of energy like heat energy, and therefore we can write delta u upon delta t will be equal to I phi, equation number 3. So this delta u upon delta t represents change in potential energy per unit time, and we know that change in energy per unit time is nothing but power, and therefore it will be equal to I phi. Therefore we can write power P equal to delta u upon delta t equal to I phi. That is, the electric power is the product of current and the potential difference, that is I phi, equation number 4. Now due to the applied electric field, free electrons move across the resistor, and hence there will be increase in its energy of the electrons. Similarly, the power is transferred by the cell to the resistor, and that power P is equal to I phi. This power is transferred to that resistor. Now when that applied electric field is there, at that time free electrons move across the resistor, and hence there will be increase in its kinetic energy of the electrons. Due to the applied electric field, the electrons will be set into motion, and hence due to the motion these electrons will possess kinetic energy. And when these electrons, if you consider these electrons, when these electrons collide with these ion cores, at that time the energy gain by them is shared among the ion cores. So when these electrons collide with the ion cores, the energy gain by them is shared among the ion cores, and hence the vibrations of the ion cores increase. The vibrations of these ion cores will increase, resulting in heating up of the resistor, and thus some amount of energy is dissipated in the form of heat energy in that resistor. So when electric field is applied to this resistor, at that time electrons are moving across this. Due to the collisions between the electrons, there will be dissipation of the energy will be lost, and hence due to the resistance offered by this resistor for the flow of current, hence heat energy will be produced there, and therefore that resistance gets heated. Now from equation 4, from this equation 4, and by using Ohm's law, that is phi equal to IR. So from equation 4 and by using Ohm's law, that is phi equal to IR or I is equal to phi by R, we can write that equation 4 as P equal to, this P equal to phi square by R, because P is equal to I into phi. In place of I, we can write phi by R, and therefore phi by R means phi by R into phi, we will get phi square by R, since reason is given I equal to phi by R. Similarly, again it will be written as P equal to I square R. Again from equation number 4, in place of this phi, if we write IR, then I square R this will be the power, and therefore since V is equal to IR, so by using Ohm's law and equation number 4, we will get this equation. So in this way, from equation 4 and 5, it is clear that the electric power P is given as IV or V square by R or I square R. All these three equations will give us the electric power. And now let us see the next point, that is resistors. Now we know that the resistors are used to limit or control the current flowing through any circuit. So current flowing through any circuit will be controlled or limited by using the resistors. Now if you consider these resistors, then there are two types of resistors, that is carbon resistors and wire wound resistance. Carbon resistors and wire wound resistance. Now high value of resistors are for carbon resistors. High value resistors will be carbon resistors. Similarly, carbon resistors are small in size and inexpensive, and therefore carbon resistances are widely used. Now the value of these resistors can be calculated by using color code method, in which the color rings are marked on the body of these carbon resistors, and therefore let us see what is the procedure to find the value of any given resistor by using color code method. So in order to find that value, here one table is given. It is having total 5 columns. First column contains color, which will be marked in the form of rings on the body of resistor. Then second column is first digit, so it will give us first number in the value of resistance. Next is second digit, it will give us second number in the value of resistor. The next column is multiplier, so these two digits will be multiplied by this multiplier in the value of resistance, and the last column will give us the tolerance in the value of resistance, that is the variation in the value of resistance, less or more variation in the value of resistance will be given by this tolerance. Now if you consider this table, the colors are arranged in the decreasing order of their brightness. So first of all, very dark current will be there, and at last there will be very light current. And so these currents are black, brown, red, orange, yellow, green, blue, violet, gray, white, and next to it is gold, silver, and at last there will be no color. So these are some of the colors given here. Then first digit will contain 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. There will be no digit for these last three, that is gold, silver and no color. Similarly, same values for second digit will be there starting from 0 to 9, and again there will be no second digit for gold, silver and no color. Now if you consider the multipliers, then these multipliers are 10 raised to 0, 10 raised to 1, 10 raised to 2, 10 raised to 3, 10 raised to 4, 10 raised to 5, 10 raised to 6, 10 raised to 7, 10 raised to 8, 10 raised to 9 up to white. And for gold it is 10 raised to -1, and for silver it is 10 raised to -2. Then in the last column there is tolerance. Now that tolerance will be given as, for black color there will be no tolerance. For second color, that is brown, it is ±1%. So very small variation will be there in the value of resistance. Then slightly larger than it will be for red color, that is ±2%. From red color to white color, then there will be no tolerance for these colors. Then for gold it is ±5%, for silver it is ±10%, and for no color, if there is no color, then it will be 20%. So ±20%, that will be the tolerance for no color. Now by using this table, we can calculate the value of any given resistor, and therefore in order to find the value of resistor, let us consider one example. So in this case, a resistor is shown having two terminals, and there are 1, 2, 3 and 4 different color rings marked on the body of that resistor. So sometimes there will be either 3 rings, that is minimum 3 color rings will be there, and maximum 4 color rings will be there. Either 3 or 4 color rings will be marked on the body of resistor. Now let us see what is the procedure to find out the value of this resistor by observing only the rings. Now these 3 rings are very close, and they are close to this left end, and therefore this will first, this will be second, this will be third color ring, and fourth color ring is far away, and therefore it is separated from these 3, therefore it is fourth color ring. Now what is the procedure? Let us see. First of all, the first color ring will represent the first digit in the value of resistance. First color ring will represent first digit in the value of resistance. Second color ring will represent second digit in the value of resistance. So this will give us second digit in the value of resistance. So first and second color rings will represent the first and second digit in the value of resistance. Then third color ring will represent the multiplier in the form of power of 10. This third color will represent multiplier, and the fourth color, if there, then it will represent the tolerance in the value of resistance. If fourth color is present, we can write its tolerance by observing from that table. If fourth color ring is absent, then directly we can write plus minus 20% for no color, that will be the tolerance. Now in this example, there are 4 color rings. First color ring is yellow in color, second is violet in color, third is orange in color, and fourth is gold in color. So we will have to find out its values. Now let us consider for the first digit, that is first color ring is yellow, and therefore we have for yellow color, for this yellow color first digit is 4, and therefore it is written here 4. Then for violet color it will be 7. So for this violet color it is second digit, that is 7. Then third color ring is orange. So for orange, for this orange color, multiplier is 10 raised to 3, and therefore here it is written 10 raised to 3. And fourth color ring is of gold, therefore for this gold there will be plus minus 5%, and therefore the value of that resistance will be written as, first of all 2 digits, that is 47, into multiplier, that is into 10 raised to 3 ohm, plus minus tolerance is 5%. It can also be written as multiplying 47 by 10 raised to 3, it will be 47,000 ohm plus minus 5%. In terms of kilo ohm, it will be written as dividing this 47,000 by 1000, we will get 47 kilo ohm plus minus 5%. So like this, the values of the resistances can be calculated by using the color code method. So in order to find out the value of resistances by using color code method, this table must be remembered, and in order to remember this table, one more statement will be stated how to remember these colors. So the initial letters from all the colors will be now considered, that is B, B, R, O, Y, G, B, F, G, W, then G, S and N. All these initial letters will be considered, and therefore one statement will be written there as B, B, Roy, B, B, Roy, that is R, O, Y, B, B, Roy, Great Britain, very good wife, gold silver necklace. So B.B. Roy, Great Britain, very good wife, gold silver necklace. So by remembering this statement, we can prepare that table for the values of resistances. So if the question is asked, then sometimes like this figure will be given, the color rings will be marked there, their colors will be written here, and then you will have to find out the value of that resistor. Sometimes only serially colors are given like this, 3 or 4 colors, that is yellow, violet, orange, gold, and then you will have to find out its value. By the same procedure, in both these cases we can find the value of resistance. So this will be the color code method to determine the value of given resistor. And now let us see next one, that is rheostat, which is, so these resistances are carbon resistances for which we have calculated value, and this will be the resistor which is wire wound resistor, that is rheostat. So if you consider the rheostat, what is the use of this rheostat? So the rheostat is a adjustable resistor. So if you consider carbon resistors, its value will be constant. But in case of wire wound resistance like rheostat, the resistance of that rheostat can be adjusted, can be increased or decreased. Now this rheostat can be used to adjust the potential difference. It will be used to adjust the potential difference between 2 points in a circuit. Similarly, it will be used to change the intensity of light. Similarly, it will be used to control the speed of motors. So with the help of this rheostat, we can adjust the potential difference, we can adjust the intensity of light, as well as we can control the speed of motors. Now its resistive element, that is in this case the cylindrical form is there. So these small curves on the body of this cylinder will represent the number of turns of the conducting wire. Very thin wire will be taken, and therefore in case of rheostats we can say that its resistive element can be metal wire or a ribbon. That wire will be in the form of thin wire or in the form of ribbon or carbon films or conducting liquid, depending upon the application. So for what purpose that rheostat will be used, that will decide the shape of that element, that is in the form of wire or ribbon or carbon films or any conducting liquid. And in some of the experiments, these rheostats are used for volume control. So sound will be controlled with the help of this rheostat. So this will be the body of this rheostat. Then there will be stand for the support for this rheostat. Then this cylindrical body will be wound with large number of very thin conducting metallic wire. Then above that there will be a slider. So when this slider is moved to and fro, at that time the resistance of this rheostat will be changed. So by sliding that slider, the resistance of the rheostat can be changed, either increase or decrease.